Yes, dear all, welcome to the video. In this video, I am discussing on inverse jet transform. I hope you already familiar with Laplace transform and inverse Laplace transform. While finding inverse Laplace transform, we used partial fraction method and convolution theorem. In the same way, while finding inverse jet transform, here also we are using partial fraction method and convolution theorem. Mainly I am focusing on partial fraction. Before going to the partial fraction method, let us learn what is the definition of jet transform. Okay, definition: z of f of n being clearly a function of z is briefly written as f of z. That is, z of f of n is equals to capital F of z. This is known as jet transform definition, where f of z is equals to summation runs from n is equals to 0 to infinity f of n z power minus n. So mainly here you need to remember this notation: z of f of n is equals to f of z is known as z transform definition. And to get the inverse z transform, here z you send it to RHS side, it becomes z inverse of f of z is equals to f of n. So this is the inverse z transform definition. So when you are sending this z to the RHS side, it becomes z inverse of capital F of z is equals to f of n. So this is the notation of or the definition of z transform. Okay, inverse z transform. Then here z is known as z transform parameter. If you remember, in Laplace transform, L is known as Laplace transform parameter. In the same way, here z is known as z transform parameter. Now let us focus on inversion by partial fractions. Now let us see some key points to find inverse jet transform by partial fraction method. Of course, there are several methods to find inverse jet transform. Few methods are partial fraction method, power series method, residue method, and by using convolution theorem also we can find inverse of jet transform. But in this video I am going to discuss about inversion, that is inverse jet transform by partial fraction. So let us see few points before going to the problems. First point: to find the inverse jet transform of functions of the form f of z by g of z, we shall use method of partial fractions. Here f of z is numerator term and g of z is denominator term. And if the function or if the expression capital F of z is equals to rz by dz is valid for proper fractions. So you already knows about a proper fraction. Proper fraction means numerator term is that is the degree of numerator is less than the degree of denominator. So the term, the functions or the expressions are known as partial fractions. In the same way, if the expression f of z is equals to a of z plus r of z by d of z. So here when you are getting improper fractions, improper fraction is nothing but whenever your numerator degree is greater than denominator degree, then you are adding one extra term, that is a of z. So mainly we are focus on proper fractions. So how to find the inverse jet transform of proper fractions? Okay, here we convert f of z by z into partial fractions and not that of capital F of z. Here while finding inverse jet transform of any given function, so let us proceed in the same way. Let f of z by z is equals to a by z minus a plus b by z minus b plus c by z minus b whole square plus d by z minus b whole cube. Here LHS side you are keeping f of z by z always, and the RHS term, for RHS term you are applying partial fraction. Then you send this denominator z to RHS side, then you are getting f of z is equals to a into z by z minus a plus b into z by z minus b plus c into z by z minus b whole square plus d into z by z minus b whole cube. Then after this step you apply inverse jet transform on both sides. Therefore you are getting z inverse of f of z is equals to a into z inverse of z by z minus a plus b into z inverse of z by z minus b plus c into z inverse of z by z minus b whole square plus d into z inverse of z by z minus b whole cube. Okay, so this is the obvious procedure we are following to find inverse Z transform by partial fraction method. So let us understand well with the help of examples. Okay, yes, let us learn some problems based on partial fraction method. Here usually in problems they will ask first problem, find Z inverse of, or they will ask find the inverse of Z transform for the given expression, or they may ask evaluate the given expression. Here in first example they are asking find Z inverse of z divided by z square plus 11z plus 25. We need to find inverse Z transform for this expression. So let us find the solution here. Here take the given expression as capital F of z. Given expression is z by z square plus 11z plus 24. This expression you take it as capital F of z always. So solution part, let f of z is equals to this expression. Then here this numerator z. So numerator z, power of z is 1. Here in denominator highest power of z is 2. Therefore it is proper fraction. So then here the numerator term z and the denominator term z square plus 11z plus 24. It is a quadratic equation. You find the factors of this quadratic equation. Let us find here z square plus 11z plus 24. Here if you multiply 8 into 3 you are getting 24. If you add 8 plus 3 you are getting 11. So therefore use this and find the factors. Here factors for this quadratic equation is z plus 3 into z plus 8. So here in place of z square plus 11z plus 24 you replace z plus 3 into z plus 8. So therefore your above expression becomes f of z is equals to z by z plus 3 into z plus 8. Now send this z to LHS side. It becomes f of z by z is equals to 1 divided by z plus 3 into z plus 8. So your LHS expression is f of z by z and RHS expression is 1 by z plus 3 into z plus 8. Now you apply partial fraction on RHS side. It becomes a divided by z plus 3 plus b divided by z plus 8. You take it as equation 1. Then if you take LCM is z plus 3 into z plus 8. You are getting 1 divided by a into z plus 8 plus b into z plus 3. You take it as equation 2. Here easily can get the constant values. Here z plus 8. If you use z is equals to minus 8, so this term will vanishes. You are getting b value. So if you substitute z is equals to minus 8 in equation 2, then your first term becomes 0. Then 1 is equals to b into, in place of z substitute minus 8, then it becomes 1 is equals to minus 5b. Therefore b value is minus 1 by 5. So here the second term contains b into z plus 3. In place of z if you substitute minus 3, then this second term going to be 0, then you are getting a value. So put z is equals to minus 3 in equation 2. Therefore 1 is equals to a into, in place of z, minus 3 plus 8, second term is 0. So therefore if you solve this, 1 is equals to 5a, a value is 1 by 5. So therefore here a value is 1 by 5 and b value is minus 1 by 5. So use these a and b values in equation 1. Therefore here you are getting f of z by z is equals to 1 by 5 into z plus 3 minus 1 by 5 into z plus 8, because a value is 1 by 5 and b value is minus 1 by 5. Then here LHS term is f of z by z. Send this z to RHS side. It becomes f of z is equals to z by 5 into z plus 3 minus z by 5 into z plus 8. Now take inverse z transform on both sides. Then z inverse of f of z is equals to z inverse of z by 5 into z plus 3 minus z by 5 into z plus 8. Here again you apply z inverse for the individual terms. Here z inverse of f of z. Here in the given expression, you know what is the f of z value. They are mentioned in the problem. F of z is z by z square plus 11z plus 24 is equals to. Here 1 by 5 is constant term. Take it outside. By using linearity property, we are writing 1 by 5 outside. 1 by 5 into z inverse of z by z plus 3 minus z inverse of z by z plus 8. Now you need to go by the formulas. Here you need to remember the formula. Z of an is equals to z by z minus a. So if you send z to RHS side, it becomes z inverse of z by z minus a gives a power an. So this is z transform of an. This is inverse z transform of z by z minus a gives a power an. So using this formula, so it is in the same pattern. Z by z minus a. Here you are having z by z plus 3. You can write it as z by z minus of 3. Therefore your a value is minus 3. You can write using this formula minus 3 power n, using the definition of inverse z transform. In the same way here, second term z inverse of z by z plus 8. Here again in place of a you are having 8. So you can rewrite this term as z by z minus of 8. So therefore a value is minus 8. So you can get here minus 8 power n. So this is inverse z transform of z by z minus z minus of minus 3 is minus 3 power n, using this formula. In the same way, z inverse of z by z minus of minus 8 is minus 8 power n. Therefore inverse z transform of z by z square plus 11z plus 24 is 1 by 5 into minus 3 power n minus of minus 8 power n is the inverse z transform of this given expression. Okay. So in next video I am going to discuss about few more example. Please keep watching.